I assume your teacher want this to be the standard, base table, right?
Yeah.
Okay. So I won't be writing that. I think you're okay with this values, right? Like the parent function one. I think it's a parent function one. Now let me double check here. This is actually. Oh yeah, yes, of course. This is actually for positive and negative. Is that okay? This is for positive and negative. I hope you're okay with that. And if you compute that, do you need me to show you how you got the 8, -1 and all that? You okay? You want me to show it? Yeah, let me show it. Oh, you sure? Yeah, it's really from here. It's from this parent function one. Okay? Oops, I can't box that.
Yeah.
So this is where it's coming from. So right here, the table. Okay, now you may want to be comfortable with this. I may ask you first, how you got this, so that you may, so it's thinking cap, right, that you're gonna have on. Opposite here, you can see that, and the y, it will be exact same coefficient, but this would be like the y portion. So that's your y right there, plus 7 back here. Are you okay with this too? Yeah?
Yeah.
Okay, let's do it. Let's do the transformation table, but I'll go ahead and leave the xy parent function blank. I'll even write the skeleton of that. So let's do the transformation table. So I think you can see for the x column, it's going to be x minus 6. You okay for that one? And what about the y? Can I ask you, let's see, how's the y? What do you think the y is going to be?
+3.
Plus 3. Not quite. You have y in it. Okay, do you want to do it? Do you want to try it again?
What? Say
Okay,
that again. Sorry.
you know how this is, how you got this from here? You want to try it for this one? Do you hear? Okay, let me refresh your memory here. The -3 is right here. But the y, guess what the y is? The y is this chunk right here. You can think of that as a chunk of y. It is actually the core of the y. It's like this is the y, the whole thing. I'm sorry, this is the whole thing. It's like the parent function, but it has the shift, the opposite x horizontal shift. This is opposite. It's always opposite. So it's opposite here for the horizontal shift. Okay, I'll do this one. So to do the y, you have to actually write 1 times the y. So let me write it. 1 y. I'll emphasize the 1. You don't have to write the y. And then -3. This has to be the way you do it. So let me actually go ahead and do the other one before you even fill in the blank, so that you actually can see the pattern to it. So the table of this one. Oh yeah, the x and y. Okay, now for this one. Okay, let me do this one first. The x, you see it's going to be x minus 6. Is that okay? And then the y, what do you think the y is going to be? The y column, the label for the y column. Let me write it neatly here. Opposite here.
2y minus 1.
Yes, 2y minus 1. So there you go. That means this one, what do you think this one is going to be? So x minus 8, I think you're okay with that?
Yeah. And then 1/4 y minus 1.
That's it. So you just kind of get used to it, or memorize it if necessary. Yeah. Okay, now we'll go complete the other ones. Let's continue with this. You remember how to do this? Like you'll be using these values and then subtract 6.
Yeah.
Right? Yeah, it's not fun. I actually don't like this because I can do this so much faster than you can imagine. I'm not kidding, because this is, when you get into pre-cal, you no longer have to do this and beyond. Yeah, anyway, we have to go abide by that. So, yeah, I should be copying this, but let's just come back and look at this. It's faster, okay? So anyway, x minus 6 is going to be -2 minus 6, so it's -8. Double check my math, okay? -1 minus 6, -7. 0 minus 6, it's going to be -6. And 1 minus 6 is going to be -5. And 2 minus, I'm sorry, I think I'm doing this wrong. I want to double check here. Yes, we're doing it right. 6 minus 5. and then 2 minus 6, -4. So far, okay?
Yep.
And then the y. So you're going to use this for the y right here. So let's just kind of do it mentally if we can. So 8 times 1 plus -3, 5. -1 times 1, -1 minus 3, -4. Double check my math there. 1 times 0 is 0, minus 3 is -3. 1 times 1 is 1, minus 3, 1 minus 3, -2. 8 times 1 is 8, minus 3, it's 5. All right, let's plot this. So now I was showing you the end behavior, so expect it to look like that because it's positive. But there's more if you actually want to get ahead. It also means that you're going to actually shift the the whole thing, the whole graph in the x direction, like x is left and right, or horizontally by 6. Imagine the parent function looks like this. I think you're okay with the, I forgot to talk about the parent function. The parent function looks like this. Do you remember something about it? Like center at the origin? It's this one, by the way, the graph of this one right here. So what will happen with this particular graph is that it's going to expect it to shift. So when you do enough, you don't need this table. That's what I mean about that. By that, it's going to go like this. By looking at this, it's going to go like this. It will be opposite for the x direction, which is going to go 6 to the left and then down 3. So 6 to the left, down 3. It looks something like this. So expect to plot it so that it's 6 to the left and down 3. The center of the parent function will be like right here. There you go, something like that. Okay, now let's plot it. So that's your expectation. You know, if you learn about the HK, the transformation, it's the same for all graphs, by the way, not just third power. But okay, let's go ahead and plot this. But expect it to look like that. Okay, anyway, let's see. -8, comma 5. -8. Let's see here. -8 right here, comma 5. Okay, I'm wondering what's happening here. -8.
It looks like warped on your screen almost.
Yeah, but here's the thing though. The graph is not supposed to look like that. I think I might have made a mistake somewhere. But anyway, let's see. -7. -7. -7 minus 4. Where's -7? Minus -4 all the way down here. So there's an error here somewhere. Yeah, it's a -4. It's way down here. Is that right? No, that's -6,4. But let's do a couple more points and see what happens here. I don't know where this is here. And then -6, comma 3, -6, comma 3. Right here. -5, -2, -5, -2. -5, -2. Yeah, something's wrong here. I have to look at it. Wait, what happened to my values here? Y, 8. 8 minus 3 is 5. Okay, so last one is -4, 5. -4 and 5. Yeah, something's wrong entirely. So what's wrong here?
Yeah, it does look wrong.
Oh,
I'm not sure.
oh yeah, what is wrong here? Let me see what happens with this one. We didn't cube it. See that? Now, I would have been done by that already, by the way. Let me see here. -3 times y. But y is 8. -3 times y. -3 times 8. I'm checking this particular value right here. So -24 plus 7. Okay, what is happening here? I think you got this incorrect. It's okay. I think yeah, I didn't do this one with you. So these are not right. You know what I mean? Maybe we should fix this one first. But this actually, let me look at this. Let me double check now for the for the number one parent function. All right, let me look at it again. So, okay, let me do it again here, xy for the parent function. So you start with -2. So -2, I'll write the actual math. I'm doing the xy here, okay? So if you do -2
Okay.
for x, yeah, this -2, -1, these are standard. So let me redo this problem, right? Then what you're gonna do is that this is the parent function, okay, parent. So -2 to the third, I'll even show you the work here. That's gonna be -8. So this should be -8. Ah, okay. You see that? So I went with the value that's incorrect. So I use this value assuming it's correct. So therefore, all these are wrong here. Oh, wait, except the label, okay? Erase the label for the columns, the two columns there. All right. So let's rewrite this. You can erase it or you can actually copy this down. I recommend you even copy the work here. So here, -1 to the third. That would be a -1. -1 times -1, -1. That's going to be -1. Then 0 to the third, it would be 0. And then 1 to the third, it would be 1. 2 to the third would be 8. Okay, so replace these values here. Well, actually, you got them all right except -8. Okay. All right, that means I have to come back over here. So the x, the x will write. Oh, dang it. What was it again? -7? -6 was it, right? -5? -4? I forgot what they
think so.
were. Let me start again. So -2 minus, sorry, -8, sorry. -2 minus 6 is -8. -1, -7, 0. No, 0 minus 6 is -6. And then 1 minus 6 is -5. And then 2 minus 6 is -4. Okay, these were right. Now, we're going to use these values here. -8, -1, 0, 1, and 8. Okay, -8 times 1 is -8. Should I write that? Or, okay, -8, -8, -9, -10, -11. Like that. And -7. So everything will write thereafter. So I erased all of it. -7 for the y here. We're looking at, okay, -1. -1 minus 3 is -4. 0 be -3. Are you okay doing the math on this side?
Yeah.
And then where's my 0? 0? Yeah, there you go. 0 be -3, and then then 1 minus 3 be -2. 1 minus 3 -2, then 8 minus 3 will be 5. Okay, let's plot this again. And we'll do the other one. I think it will make sense. -8, -11. We don't even have enough space for it or scale for it. -8, and then -11. So let me see. 5, 10, -11 is way down here. Oh yeah, don't take those as my points. You can eye it, okay? But I'll try my best here. -8 times 11. Oops, not that. 8. All the way down here. So there's your -8 and 11. And then -7 and -4. -7 and -4 right here. And then -6, -3. How many -3? -6? No, that's -6. Sorry. This is not correct either. So I have to go over 8, -8. 11 right here. That's the first point. -7, -4. Right here. That's -6. That's -6. Why can't I see -8? I apologize. -8 is way over here, okay? For some reason, I keep not doing that. Okay, I can erase. So it's over here. There's -8, comma -11. So I'll erase and okay, I'll do that. -7, comma -4. And there's -7 right here. And then -4 is down here. -7, comma. And then -6, -3, -6, -3 right here. And then, so now it's becoming what I was expecting. Remember I was drawing this? It'll be like that. Okay, but let's finish it. -5, comma -2, -5, -5, comma -2 right there. And then -4, comma 5. So this one you have to curve it, okay? Be ready for this one. This one, a lot of students probably have a hard time with it. -4, and then 5, -4, and then 5 right there. But the graph will look like this if you connect it. Remember I was drawing this earlier? There you go. But I'll let you see the point first. You see it?
Mm-hmm.
So we'll go
Yeah.
like this. There you go. Now it makes sense.
Looks a lot more like what you said it would.
Yes. So that's it. So if you look at the parent function, it would look like this. But what happened with this parent function is that you shift 6 opposite here and down 3. The center of this point went 6 and down 3. See right there? It's right there now. But the idea here is that knowing your parent function, what it looks like, and then you can transform from there without having to plot them. When you go in higher math, you don't need to do one point at a time. You waste your time. Just show the transformation. Like, okay, sketch it out. So your teacher doesn't care as long as you have it close to where it should be landing. The parent function should be landing, or stretch it also. Yeah, there's some stretch factor. But there's something about that if I can see it, I'll point it out to you. You can do it much faster, by the way. Okay, from here, A, I think you're okay with the A being the coefficient, which is 1. If you don't see it, this is the A right there. If you don't see it, that's 1. And then H is here, and that's K. Let me write this. I think you recognize it. It looks like this. Here's the arrangement of all the variables here. Minus H cubed. You can copy this. I recommend you copy this down. Plus K. There you go. So now careful when you actually use this. It's minus here and it's plus here. That means if they ask for H, it will be opposite of this here. I don't know if you're okay with that. So anytime they ask for H, it will be opposite of this right here. So if you look here, it's plus 6. You're going to have to do minus 6. And the K will be as is on the back. So we'll do some more, and then I think you're going to be okay. So as is means -3. Now the transformation, easy, as I described it. So this is actually, if you do enough, you will learn it here. So let's finish this, and then we'll do the next one. It will start making more sense. So anyway, without this table, even you will be able to answer all of this without the table, the transformation table. So how? But the table just confirm the graph, basically. Okay, here. Transformation, you can say in any order. So I would go something like this. Opposite here, opposite the 6. So you're going to go left 6, or your teacher may actually want you to use the word shift, but I don't think so. Left 6, down 3. So I'll explain that. Left 6, what that means is that you always think opposite when you're describing in between the parentheses. It's left or right. So if it's plus, I know that you see plus 6, you'll say the opposite of that. So it's not right 6, it's opposite, it's left 6. But out here, the down or up, it's exactly what you see. This is minus, then you say down 3. Okay, that's so far. Now let me see what your teacher also want you to do. Right, unit. Okay, with the word units. You don't need to, but go ahead. 3 units, 6 units, 3 units. You don't need to do that. Yeah, that's too much detail. But what else? Okay, now there is no reflection. There's actually more. The stretch factor is still 1. So you don't say anything about that unless there is other number. Like for example, there is a stretch factor of 3 right here, -3. But you flip. If you have a minus, you do a reflection about the x-axis. But it seems like you don't need to explain that. You just say, hey, vertical reflection. So it's flip up and down. So they call it vertical reflection. But this one, you don't say anything. It's still facing the same direction as the parent function. If you actually asking like, hey, what are they referring to? They're referring to the parent function. What happens to the parent function? Well, it went 6 left, down 3, but you don't flip or anything. Therefore, you don't mention that at all. Okay, so that's what's going on right now. So anything else? Let me see. That's pretty much it. Unless there's something that you have to say. So that's done because everything is the exact same shape. Now, it won't be the same for this one, number 3, but let's finish this off. Okay, the inflection point, it's the same. You don't have to look at the graph. Just go ahead and opposite this and same there. Opposite that, so it's going to be -6, comma, -3. It's really the center right there. But again, you don't want to look at your graph because when you plot them, sometimes you don't get those points in here. You don't, but I know it's here, but how would you know, right? So therefore, you don't look at the graph and you don't look at the table, but you look at this instead. Opposite here, the HK. Oh yeah, see, they say HK. Therefore, if you look over here, the H is opposite and then K, the same. Is that okay?
Yeah.
I hope you're going to be okay with that because the next one we'll do, we do 5 first. We'll do 5 first before the fraction. Okay. Yeah. So it's opposite the H and the K being the same. Opposite the H is -6. The K will be the same, -3. Okay. Then domain, all real. This is the symbol for all real numbers. They use that. Okay. X-intercept. Okay. X-intercept we have to solve for. Wow. Interesting. We'll come back to that. The range is all real also because it's going up and straight down infinitely. Now, what about the domain? Well, it's the same, but it's gradually going left and right. It's like gradually, like it's covering gradually left and right. Yeah, if you zoom really, really far infinitely, it'll be all real. Now, x-intercept. Let's do the math. Remember x-intercept? X and y. X-intercept means that your 0 is for y. You have to solve for x. This is x-intercept. You can copy this down for a note if you want. X-intercept is when your y is 0, you solve for x. But then y-intercept, it's when your x is 0, then you solve for y. Okay, then let's do the math to get the x and y-intercept for number 2. If I have space, let me stretch this up. Yeah, I can see why you would want a little help here. It's a lot of detail, dude. Okay, so x-intercept, we're using this. X-intercept means you're solving for x, but your y must be 0. So I substitute y with 0, and x is here plus 6 to the third minus 3. And we're going to solve for x. So I substitute this y with 0. So I'm doing x-intercept right now. You can label x, I, and t. Add both sides by 3. So you get 3 equals the parenthesis x plus 6 to the third. And if you remember how to solve for x, wow, this is going to be pretty messy. Okay, I didn't have enough space there, but I'll move it over here. So you have to cube root. You remember it? To cube root both sides. You cube root both sides. So the answer is going to look awkward. You don't want to punch in a calculator to get a decimal value or anything. Just leave it as the way you see it. But let me show you. So if you cube root both sides, the left side stay as is. No plus or minus because it's odd power. So there's no plus or minus. If it's square root, you will have a plus or minus on the other side, away from the x. So here is what you get. The parenthesis drop down. Let me see if you're okay with this. If you cube root here, it will drop what's inside the root. So far, do you remember something about that? I think your teacher did the both side thing, and your teacher would write just the base, like the x plus 6 part, and the 3 will go away. Like this thing will cancel like that, but don't write that. I mean, it's kind of weird. You could write that, and then final answer is subtract both sides by 6, and you're done. Your goal is to get the x by itself. So this is your x-intercept, which is quite fancy looking. You can put it in the back, but I recommend you put it in the front. It's -6 plus cube root of 3. That is your x-intercept, dude. It's odd looking answer. So why don't you have x-intercept here? What is happening there, dude? Okay.
They're different on each one. I'm not sure why.
Yeah, okay.
But
I know, huh? All right. So I don't recommend you put a coordinate. Like, it's really the same thing. Let me explain. This here, it's the same thing as, no kidding, okay? If you punch in the calculator, it's approximate value. But if you don't punch in, you have to keep it as exact answer, exact value. So this is what it looks like if you put it in a coordinate form. Remember, we made it so that your y is 0. So this is x comma y. No kidding. In higher math, you get to see the x value or any value as is looking like that. It's weird, but I think you've seen it. I'm sure your teacher probably mentioned that. So anyway, you can either write the coordinate form or just the x value. I don't know, depending on what your teacher is, but there's not enough space. What do you think? You want to do the x and y coordinate, or you want to just write the x value here for the x-intercept?
She usually does the coordinate, so.
Okay, that means, okay, good, let's do it. Try to squeeze that in, okay? Oh my, okay. It's -6, okay, I got it. Okay, I'm trying to squeeze in. It's -6 plus cube root of 3. Cube root of 3. I hope you're okay. Cube root of 3, comma, 0. Parenthesize them. Cube root of 3, -6 plus cube root of 3, comma, 0. Now, the y-intercept is easy. You're going to use the function here, right? You're going to solve for y when your x is 0. So substitute x with 0, like that. So we'll clean it up. It's just going to be 6 to the third. I'm not that smart. 36 times 6, what is that? Or 6 to the third. You can use a calculator for this one. So 6 to the third is 216 minus 6. 216 minus 6. So it's going to be 210. Now, if you want to know what's going on there, I'll explain. So it's 210. It's going to be 0, comma 210.
Yeah.
So what that means is this. If you continue graphing this, way up there, way up there, way up there, you continue graphing this, it's where 210, it's going to cross 210 up there. Imagine that. Yeah, no kidding. It won't coil back this way or anything. It will continue increasing. Get it? Like until it touches the y-axis. But it's just our sketch. It's okay. Oh, axis symmetry. Okay. Now, let's see. What did the teachers say? Oh, I see. I begin to understand now. Your teacher gave you different type of characteristic to fill in. So this one, axis symmetry, there is none. You know why, right? Axis symmetry, for example, if you have one that looks like this, then axis symmetry will be right there, like mirror image. But this one has no symmetry. You might think, what about the diagonal one? No. What about the one over here? No. If it goes sideways, it will look like this. Get it? Symmetry. No. So therefore, there's no axis symmetry. So I don't know, none? Or DNE does not exist? The teacher might use that. They use that in calculus. DNE does not exist. I don't know. But you can just say none. Okay, let's do the 5 first because you want to get used to it before you get kind of, what do you call it? Confused with the fraction, like the coefficient with the 1/4 thing. Let's do this one first. All right. I guess we do the table again. I guess I'll copy the table quickly. The parent function table. This is the parent function. So -2, -1, 0, 1, 2, and then -8, -1, 0, 1, 8. Okay. All right. Let's do the transformation table. All right. Help me do the transformation table. What's on here? What's up here? The label for the X column. What do you think?
For X, you
Opposite?
do. Yeah, so you do X plus 1.
And the Y?
And then for the Y, you do -1Y plus 2.
Got it. Nice. Okay, that's it. All right, let's use this X value and the Y value to compute. All right, I don't like this at all. I don't enjoy doing it because I know what the graph looks like. I'm not kidding. I sketch it real fast. And I can get the point accurately even. Yeah, but right now it's a learning thing. They want you to 5 points. Yeah, because of the curve. Most often you only need to do 3, but the curve, if it's kind of like curvy and it looks kind of not common, you have to do 5 at least, sometime more. All right, -2 plus 1 is -1. -1 plus 1 is 0. I'll try to align the column, the rows here. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Are you okay? In that? Yeah. Okay, -8 times 1. Let's try to mentally do this. -8 times -1 is 8. Plus 2 is 10. -1 times -1 is 1. Plus 2 is 3. 0 times -1 is 0. Plus 2 is still 2. 1 times negative 1 is negative 1 plus 2. Negative 1 plus 2 is 1. Do I need to write that work, or do you think you're okay doing it? You have to be careful doing it, okay? Yeah, be careful doing it. So 8 times negative 1, 8 is the y, is 8. Times negative 1 is negative 8. Negative 8 plus 2 is negative 6. All right, let's plot this. Now, before I plot it, let me tell you what it looks like, if you want to know. So the parent function, once again, look, this is why you want a, yeah, in pre-cal, you have to do it, dude. There's no, you don't do this table, unlikely, but you have to sketch out the graph real fast. Let me kind of give you the pre-cal way. So this is the parent function. What's going to happen with that is that it's going to flip because of the negative 1. And after you flip it, you will shift to the right one opposite and then up 2. So here we go. I'll do it in the order I said it. I'll flip, so I'll write it lightly. I'll flip that, and I'll try to memorize that. So it looks like that right now, and then I'm going to shift 1 over. So it's going to look something like this, 1 over, and then up 2. So in the final graph, it will look something like this, about something like that. But yeah, it's a little bit fat, but it's something like that. Okay, anyway, let me erase this. So it would be, oops, I got my next. So it'll be something like this. Okay, ready to connect it. So all right, let's plot this. Negative 1, 10, all the way up here. Negative 1, 10. So it should be here. 0, 3, 0, 3 right here. 1, comma 2, 1, comma 2 right there. So that is, guess what? This is your HK. How do I know? Opposite here. Let me see. HK. Opposite, same, HK. So that's your HK. Just be ready. I'll even label this HK right now. Now, how do you know that? You just go ahead and, I recommend you memorize this right here. Yeah, write it somewhere above. H is opposite, K is the same on the outside. It's actually all for all HK form, quadratic, like square, not just cube functions. All right, continue. Sorry. 2 comma 1. So 2 comma 1 is right here. 2 for x, 1 for y. Then 3, negative 6. 3 and all the way down, negative 6. 3. Wait, see, I got my 2 wrong. 2 comma 1. Is that right? Yeah, 2 comma 1 is right. So 3, negative 6. 3, negative 6. That's negative 5. Negative 6 right here. That's it. There it is. So the graph will look like this. That's I sketched earlier. Here, I'll undo it. So here are the points, and connect them. There it is. You can do the arrow thing to indicate that it continues. They both continue, both arrows and arrows. Right. A is negative 1. H is opposite here, opposite the inside the parenthesis, opposite next to the x is opposite, so it's 1 plus 1 if you want. The k will be the same outside. Here's your k, so it's 2. Transformation. The way I described it earlier, but now you have to include the flip. Oh, I said that. It's okay, reflect. I'll use the same type of phrase that your teacher used here. Vertical reflection. So you're going to do vertical reflection. Reflection. Sorry, so wrong. Okay, that's one thing. You can do it in order, technically. And then you say something like, right 1, opposite here. Right 1 unit. And then up 2 units. Up 2 units. And that's it. There is nothing else. And then inflection point, which is your center point, is your HK. So it's 1 comma 2. I don't recommend you look at the table. I recommend you come back up here and look at the opposite inside the parenthesis for X, same for Y. So 1 comma 2. Get used to that. This is actually common for all functions. Opposite, if you ever have a parenthesis with the X inside, you always do the opposite for the H, but on the outside is always the same for the K. Okay, domain, all real, range, all real. Just do what we know fast. X-intercept, y-intercept, wait, function, yes or no? Yes, because if you do vertical line test, it will always cut through once. Now, it's not going to be straight, If it's straight, then it's not going to be a function. But it's going to curve, like I'm exaggerating. It will never be straight here. So therefore, it will always pass vertical line test every time if you, like when you do this. Is that okay? So it's going to be a function, so it's a yes. It's never curved back out. If it curves like this, I'm making this up. If it come back like this, it's not a function because it touches two places. Is that okay? I think you know
Yeah.
that. Yeah, it's kind of be doing this quite a bit. So where is that function? Yes. Y-intercept, all right. X-intercept and Y-intercept. Okay, let's do the same thing. That's not fun, but let's do it. X-intercept, Y-intercept. X-intercept means you solve for X, Y be 0. You can think that. You don't have to look at the table every single time. So you're going to solve for X, therefore Y got to be 0. So it's going to be negative X. So I'm doing X-intercept first. I don't know, I'll do that. X minus 1 cubed plus 2. Okay. All right. Subtract both sides by 2. I'll get negative 2 equals negative parenthesis X minus 1 cubed. Double check, yeah. Go back, look at the original. Subtract both sides by 2. And then you have to divide both sides by negative 1 to get rid of that negative here. So it'll be 2 on this side. It'll be positive on the other side before you cube root it. But stop me if you sure. If it, yeah. Okay, so far okay?
Mm-hmm.
Then cube root both sides. Cubed. Okay, and then you get a cube root of 2 equals X minus 1. You drop the base. This is 2. Then add both sides by 1. So here's the final. Put the 1 in the front of it. Add both sides by 1, but leave the 1 in the front of cube root of 2 equals X. And that's it. And then we'll put it in the slot here for X-intercept. So it's a 1. Okay, I remember it. It'll be 1 plus cube root of 2. No, square root cube root of 2, comma 0. And if you do Y-intercept, I want some space here, but Y-intercept, I can see it from here. So Y-intercept, it'll be Y. You solve for Y, therefore Y stays. But X is 0 now. Oops, I have to erase all this. X of 0, sorry. You solve for Y, but X must be 0. 1 cubed plus 2. Careful on this one because yeah, I can tell a lot of students can make a mistake right here. So negative 1 stay negative 1. I'll put a 1 here to emphasize that. But if you do order operation, you're doing between the parentheses, so you're just left with 1 to the third power. It's negative 1 times negative 1 times negative. It's still going to be negative 1. That's independent from the outside. So this here turns into negative 1 plus 2. If you continue, this is Y, okay? It'll be positive 1 plus 2. Therefore, it's 3. So your Y-intercept is 0, comma 3.
Mm-hmm.
And if you look at the graph, there it is, your Y-intercept.
Yep.
I think we didn't have to actually do the math. We recognize it on the graph, but we did the math to prove it. Okay, your Y-intercept there. Right, let's do this one. This is the easiest one, I think. Well, no, because maybe the negative 2, but we still have that table over there. So let's do the transformation table right away. Do you want to try this one? So what do you think the X, this is the transformation one, okay? What do you think the X is going to be?
1 second, let me write the table down.
Okay.
Okay, it'll be, can it just be like, would it be X plus 1 or just X?
Just X.
Can it,
Is that
just X?
okay? Yeah. But you know why? Because you don't have anything like around it, right? You know, with the parenthesis. Is that okay? Yeah, just X. Okay. And then what about the Y?
Negative 2Y minus 7.
Yep. That's it. All right. Very good. Let's do the math. So we're going to use this parent function table. So negative, the easy thing is that you just copy the X, all of it, you know? Yeah, right?
Yeah.
And then the Y be negative 8, negative 1, 0, 1, and 8. So negative 8 times negative 2, that is positive 16. Positive 16 minus 7, that is 9. Yeah, you can write it out, okay? But I think you know it. Okay, negative 1 times negative 2, or negative 2 times negative 1, that's a positive 2. Positive 2 minus 7, that is minus 5, negative 5. 0 times negative 2, or negative 2 times 0, is 0 minus 7, negative 7. And 1, okay, negative 2 times 1, minus 7. Negative 2 times 1, negative 2, minus 7 is negative 9. And then 8, negative 2 times 8 is negative 16. Negative 16 minus 7, negative 16 minus 7, that's going to be negative 23, I think. I have to write it out to look at it. What is that? Negative 16. Is that right? Yeah, negative 16 minus 7. Yeah. Oh, yeah, let's plot this. You can't plot negative 23, but to kind of like exaggerate a little bit.
Mm-hmm.
All right, let's do negative 2 comma 9, negative 2 comma 9. Right here. Because that it's 10, up, 10, down, 10, left, and right. Negative 1, negative 1 comma negative 5. Right here. And 0. Oh, I didn't tell you what it would look like ahead of time, but let's continue with that. It might be an error already somewhere. I don't think so. Anyway, negative 1, negative. Okay, 0 comma negative 7. 5, 6, 7. Yeah, it's right. I'll explain. The reason is because it's only a portion. You don't see the rest of it. It's going to be like this. Imagine down. You know what I'm saying? And HK is this one. But you got to look here though. H, if you don't see in the parenthesis, it's 0. Is that okay? Like if you don't see anything opposite, like in between the parenthesis to do opposite with, it will be 0. 0 comma negative 7. So that's your HK right here. Yeah, you can label that HK. Okay. Then, wait. And then negative, I'm sorry, 1 negative, and then you do 1 negative 9. So 1 negative 9 here. And then 2 negative 23. So we're going to exaggerate in 2 negative 23. So way down here somewhere. So I'm going to go like right around here. And then if you connect them, be like that. Is that okay?
Mm-hmm.
There it is. So it's correct. All right. Then A is, okay, A being negative 2. H, 0. You don't have any parenthesis around the X and a number with it. 0. K is negative 7, as is. Outside as is. Transformation, okay. We'll do the reflection, and then the stretch factor. I don't see anything here, because the 2. Oh, wait, there is a 3, but let me see what your teacher said. Vertical reflection minus 3. Well, vertical reflection is just a negative. I guess let's fix this here. Vertical reflection is just a negative, but then you have to say stretch factor of 3. It's not negative 3 exactly. But do you remember what your teacher said? Are you sure that your teacher, or did you do this in class? Because it's not really true.
That's what but it just means to multiply the y by whatever number that is.
Sure. Yes. Okay. So, but I recommend if your teacher did not write this, I recommend you change it. Is that okay?
Mm-hmm.
Yeah. So you have to say something like this: the vertical reflection is correct, but then you have to say the vertical reflection only referring to the negative part. The 3 is, you have to kind of separate them, right? So you can actually, I would recommend you erase the negative 3 entirely, and then write something about the 3. You already got the negative part, the vertical reflection, but then you have to say stretch by a factor of 3.
Mm-hmm.
By a factor of 3. Of 3. Of 3. Yeah, we got the vertical because of the negative. It's kind of separate. How about that? It's a separate thing. But the 3 is the coefficient, the stretch factor. For this one, therefore, you'll be doing the same. But you want to say the reflection, about vertical reflection. So let's do vertical reflection because of the negative. Reflection. And then you're going to say stretch, comma, like continue, stretch by a factor of 2.
Mm-hmm.
Now, it may be phrased a little different, but this is common. I'm just writing the way it's kind of universally written everywhere. Start by 2. Sometimes they say by 2, but I think you need the word factor in there. Factor of 2. And then you can say the HK part. So since you're not moving left or right, see the H, there's no H, so you don't have to mention that at all. But then you have to say down 7 unit. That's it. If you're not moving left and right, why is it not moving right? Why the parent function is right here? So yeah, you didn't move it. You didn't move left and right. It's still there, but it's shipped down only. You can imagine that? Yeah, it's shipped down and stretched by a factor of 2. So anyway, all you do is just say down. I'll capitalize it. Down 7 unit. That's it. Oh, if I can point. So we already got it. It's 0, -7. Okay, now I'll let you do y-intercept, but let's talk about increasing, and yeah, do this one, okay? I'll leave it blank. Increasing interval, none. Let me explain. None. When you look at the graph in math, any graph, you have to look from left to right. You have to scan from left to right, just like reading a book, but it's always, this is very important. I don't even think reading a book is just something I'm used to. You have to know it. If you analyze the graph, you have to scan from left to right. This is very important in calculus, very important in pre-cal. Always you'll be taught to scan from left to right, look at the graph. If you look at the graph right now, from left to right, you don't see it's going up. It's going down. You see it? From left to right, it's going down. Therefore, there is no increasing interval. But what about decreasing? Yes. So therefore, you want to say negative infinity to positive infinity. Is that okay? Yeah. You can ask me if you're not sure. So yeah, you are using the interval notation. Yes. Okay, I see. Your teacher used NA, not available. Whatever, none, not available. NA. You can do NA if you want. NA. I'll say none. Max min? No, none. NA. Slash NA. Now, when do you know when you get max and min? When there's more x. Look, this stuff your teacher is supposed to teach you. Like this. This is max and min. I was saying earlier, but you can only get that if you have more x involved. What do you mean? You have to have x squared plus x plus 5. You see the rest of the, how you don't have x to the third for this one though, for this one. Now, it's not the same as this one. They didn't ask you for a reason because you don't know how to get the answer from there. You can't not find it because that requires another concept. But they asked you this one because they want you to identify that there's no hump because it's coming just from the parent function. Therefore, it looks the same as parent. Parent function does not have the hump. Therefore, there is no max and min. But if you do more math, which you might, to get the hump, you'll get x squared as part of x cubed and then some x maybe, and then you get the hump. But that's complicated stuff, which you are likely going to even deal with. Okay, so let's move on. So I think you can do the rest, but let me look for stuff that I think it's going to be difficult. You think you're going to be okay with the fraction too? Like with the 1/4? Yeah, let me see if there's something here. Oh, wow. Max and min. Uh-oh. Are they saying yes or no? Okay, now I'm thinking. I'm gonna grab this in a second. Can I ask, have your teacher talked about max and min? Because you don't know the concept yet. You can't solve it. Let me explain. You cannot do max and min the exact. Let me look at the graph here, for example, right? This is a max and this is a min. There is a coordinate x comma y at that point and this point. You know what I mean? But to get those points, max and min, right? You need calculus, literally calculus. So you're two years away from that. So you cannot do it unless you use a graphing calculator. Let me graph it. Let me see what it looks like. Because if I not FOIL it, if I multiply this, don't forget this is like this. If you were to do the math, right? X minus 2 3 times and then minus 4. Like this, right? And then minus 4. So this is the expansion. But and then 1/2 is way in the front. Negative 1/2 is way in the front. But let me go ahead and grab this and see if there's a hump. If there is a hump, that means you just say yes or no. You know what I mean? Like you're supposed to know that it does exist. And let's see. Because if you multiply this out, like FOIL it and then times it again, like FOIL and then times the third one, right? You're likely going to get a second power and beyond. Every time you get that, you get a hump. But that thing, it had to be taught. Your teacher kind of, or at least mention it. Hey, you can see that. Then therefore, there's a hump. So let me graph that right now. Just quickly here. So I'll even grab the 1/4 one here. Okay. Oh, but I'm in the parametric mode. I'll do basic function mode here. Okay. So let me clear this up. Okay, here we go. I'm going to punch in number 3, okay? 1/4 is the same thing, 0.25. I could put 1/4, but I'll just make it simple. And x plus 8 cubed. I'll go ahead and use the math so you see that it's exactly that. Okay, and there you go. They call pretty print. They call pretty. Okay, here you go. So this is going to be 1/4. Okay, that's the graph number 3. Let's take a look. Graph. Okay, now you might think, hey, is there a hump? No. So you're safe here. But let me double check. Let me mentally do calculus here. And there's, I can probably do mentally here. Is there a hump? Let me double check here.
The only ones I've seen us do in class, it's just you say there's no minimum and maximum.
Right. Oh, I'm sure. But yes, obviously you're not gonna be able to find the actual coordinates. But how do you know whether there is a max or min? Did you teacher mention that? So I grabbed it. Now I didn't multiply it out. But let me think here. Sometimes I have to warn you here. Sometimes the graph is deceiving. Sometimes it's there, but let me see 1 second here. Zoom in. I'm already zooming a lot, by the way. Now there's a way to do this. Let me go ahead and, so based on the graph, right, that I'm seeing right now. Oh no, okay, I know this. Sorry, my fault. I know that I mentioned about multiplying. Ignore all of that right now because it didn't come originally like that. Sorry, x squared. It didn't come like that, right? Therefore, you don't want to even attempt to do it. It's just based off the concept that you've been doing. So anyway, there is no. Let me explain. Oh yeah, I wasted my time here a little bit. Sorry. So this is about your parent function being shifted 8. Remember, let's do the fast way before you even graph it. Okay. So I think you're okay. I'll do all of it. I'll do even this one, number 4. So if you do this particular 3, I'll help you with the transformation fill in here. But you can do the math. I'm pretty sure. So what's going to happen here is that it's based off the parent function. So okay, what does that mean? Well, you're going to move the parent function opposite 8 to the left because opposite, the parenthesis, and then down 1, always the same outside. Therefore, the way I describe it, I didn't say anything about it being going up or down because it's based off the parent function. Get it? Parent function does not have a hump. It looks like this. Therefore, you only move 8 that way and then down 1. But there's one more. And then you shrink it. You shrink it by a 4th. See that? But when you shrink it, there's still no hump. When you shrink it, it will look something like this. That's what you saw in the graphing calculator. That's it.
Yeah.
So therefore, there is no hump for all of it with the HK form. That's it. So I see I'm not perfect. All these are all HK form. If you look at, here's the HK form, right, with the parenthesis and all that, and the A number in front. So all of this that you're doing are HK, including the one without the parenthesis. It's like 0. So therefore, all of this. Now, unless it's written like I was telling you earlier, if it's written explicitly like this separately, it's not written like that. Like when it's not written like this, it means that you cannot get the HK. Therefore, there is a way to get it. No, I'm sorry. Take that back. There is no HK. That's why they don't write in the parenthesis form or factor it into the parenthesis form or compute. There's certain thing you can do to make it into the HK form, but not like this. Therefore, they don't give you any of them. So none has max or min. So you can say none for sure. So if you ask for max, NA, NA, all of them, NA. They ask you again, NA, all of it. But unless they give you something else. So NA, all of it, because these are all HK for sure. All right, now let me go. I want to go and explain the 1/4, how you would word that. Okay, let's do the transformation right now. You can do it in any order. So there's no reflection because it's still positive, but it's a 4th. So something along this line, it's either the word compressed. It's likely to be compressed because if it's less than 1, you have to say compressed. But it still could be the word stretched because a 4th is still a 4th. So ask your teacher about this. Compressed by a factor of 1/4. Yeah, double check on this one. Of 1/4. But sometimes you stretch for all of it universally because it's either you're gonna go like that or shrink it. So normally when it's kind of shrink, it's compressed, and then everything else, the same. So it'll be 8 left opposite unit, 8 left unit, 8. I'm sorry, left 8 units. I'm writing it out of order, dude. I'm sorry. Yeah, left 8 units. Yeah, just it's okay. It doesn't your teacher understand units. And then down 1, comma, down 1 unit. Okay, there we go. Let me see if there's anything else. Oh, unless you need me to help you with the x and y intercept for the 4th. What do you think? You think you can do it? You want me to? You want me to do it?
For
X and y intercept.
I think I'm good.
Okay, yes. Try it. Multiply both sides by 4. After you add 1. Yeah, is that okay? And then cube root it.
Yeah.
Yeah, it's not bad. It'll be a 4 cube root of 4 on the other side. Actually, I'm sorry. Let me double check. Add 1 over. Yeah, you add 1 over because you do a y being 0 here, right? And then add 1 over, and then you multiply both sides by 4. It become a 4. Yeah, and then cube root the 4. That's it. And then then subtract 8 over. Okay, I think you're good. Good. Let me see if there's anything fancy about this. So ignore this thing. It won't turn into it will, but it can be compressed. It can be actually written as an HK automatically. There will be no hump if they can read because they gave you originally as an HK. Therefore, even if they gave you if you multiply this out, right, there's a way to compress it into this form. It's always equivalent. Therefore, it'll still be HK. Therefore, there will be no hump. Just as simple as that. Okay, now the transformation of this one, you want to say, hey, reflect about because the negative here reflect vertical reflect vertically, however you want. Okay, it's not, your teacher will be fine. Vertically or vertical reflection. I don't know. I forgot what it was, dude. What is that? Vertical reflection. Yeah, vertical reflection. It's okay. You can write reflect vertically. And then compress. It's likely okay. Less than 1. If it's a fraction compressed by a factor of 1/2. By a factor of 1/2. And then same thing. Opposite in the parenthesis. Right 2 units.
Mm-hmm.
And then down 4. Outside it's exact same. If it's negative, you down 4 units. Okay, let me see if there's anything else that looks. Okay, increasing, decreasing. Okay, let me actually show you right now. If it's negative, I was mentioning earlier, if it's negative from the beginning, it's always going to go down from left to right. Therefore, if it's negative for anything, okay, anything negative, therefore there'll be decreasing. So negative infinity, there'll be an NA here. There'll be no increasing from left to right. NA for increasing.
A is positive and it's going the other direction. Do you
Yeah.
say NA for decreasing?
Yes.
And then
Yes. Exactly. Yeah. That's right. Yes. Very good. For let's say pretend number 8, right? But then don't ask for that, right? Yeah. You'll be NA for the decreasing, right? Is that okay? Because this
and
is
then for
positive.
increasing, would it be still negative infinity infinity?
Yes. Okay. Good question. Yes. For it will still be negative infinity and positive infinity
All right.
for domain and range for all of them. Yeah. It doesn't matter if it's decreasing or increasing. Is that okay? Yeah.
Yep.
Yep. Okay. I think that's good. I don't see anything tricky except be careful when you solve for your x-intercept. But I think you're good. Watch. I'll do this quickly for number 7. Add both sides by 4. So I get 4. Oh, this one I may want to do with you just quickly. Last one here, because of the negative thing. Oh, I have to go into another layer to not erase that. I think. Okay, let me see. Nope, never mind. So it's pretend you can see through. Okay, it's 1/2 there. So okay, number 7, I'll do x-intercept. Yeah, something kind of interesting about this one. I don't know where can I write it. Yeah, it's layered, so that's why I can't. Let me go back up here. Yeah, I can do it now. Can I still erase it? No, I cannot erase it. Okay, all right, x-intercept I'm doing. x-intercept. Okay, so you'll be having 0 equals to negative 1/2 x2, but write somewhere else. I think this is for the table, but I'll take the space here, okay? Okay, cube. Add both sides by 4, so you get 4 here, but then you have just negative 1/2 x minus 2 to the third power. Here's where it's going to be strange to you. You want to multiply both sides by the reciprocal of this with the negative. So it'll be a negative 2 over 1 to both sides. Is that okay? Like, you don't need to write the 1. So it'll be reciprocal of that negative. But you want to counter the negative positive. So 2, it will be gone. It'll be a 1. And then this is what you have left. Now, here's the part where I think if you haven't done your cube root of a negative for a while, but let me continue with this. It'll be negative 8 here on this side. Here we go. Now, this is the part where student may get confused a little. You're going to cube root both sides.
Mm-hmm.
Now, can you cube root a negative? Yes, you can. Any odd root of a negative works. It's okay. Just pull out the negative. Because why? Because it's negative 2 times negative 2 times negative 2 being the answer. Now, if you're not sure, I can even prove it. But you cannot square root. So watch, I will do a cube root of a negative. Just quickly here. It will be negative. The answer is negative 2. You have to find what times what times what. 3 times, it gives you negative 8. So it's negative 2. But let me show it to you. But yeah, that's the part I just wanted to show you, point out. So let me see where the math part here. A cube root, here we go, of a negative 8. It will be negative 2. So I want to show you. I don't need the parentheses, okay? Here, enter. There you go. Ignore the decimal. And then you're left with x minus 2 here. And that's it. And you add both sides by 2. So x is 0. No problem. You just accept it. So your x-intercept is 0. So what happens is that it's going to be 0, comma 0. Now, it's not the origin. Is that right? Yeah. Y is 0, x is 0. See it? Mm-hmm. You substitute y with 0. So it's 0, comma 0. It doesn't mean the center. It's not HK, okay? It's like it's going to go through it. I'm making this up. Let me, okay, the graph is decreasing, so it's going to go through it. So I'm making this up. So it looks something like this. And then it might be somewhere here. I'm making this up. So it's not the center or anything. The HK may be somewhere else, but it's just going through the origin coincidentally as part of the graph. So it's not HK. So it's kind of, because if you think about it, the HK is opposite here. I'll write the HK right now. The HK is 2 comma negative 4. Remember? Right there. So HK, you want an HK right now for this problem is opposite in between the parentheses, comma negative 4 on the outside. So that's not HK. So it will go through, interestingly, it will go through the origin as your y-intercept. But guess what? That means your x-intercept will also be 0, 0. You don't have, you can solve it if you want, okay, but it will be 0, 0. If you go through origin, it's both. Anytime you ever go through 0, comma 0, it's both x and y-intercept. But the graph will look something, it will go in this direction, okay? I think I wrote it wrong. I think I sketched it wrong last time. It's supposed to go through it like this, but the HK may be somewhere over here. I'm making this up, okay? So it's something like this. I'm making this up right here. Actually, I know what it is. Let me look at it. It's 2 comma negative 4. So it's close. Sorry. Here's 2 comma negative 4. So actually, I'm going to sketch ahead of time right now. So here it is. So the graph looks like this. Now, you wonder why is it flattened? Because of the stretch factor is compressed. So here's the graph you want to know. And this is your HK. Mm-hmm. Something like that. Yeah, I could draw that better. This is your HK. But not 0, comma 0. So x-intercept and y-intercept will be there. You can try to plug in the 0 here for the y-intercept. It will be the same, x and y-intercept. Yeah, go for it, but it will be the same. Okay.